are evaluating, all you're simply going to do is take your original expression. Everywhere there's a variable, you're going to leave an empty space. So again, basically, you're taking just the shell of the expression. And everywhere there's a variable, you're going to replace that variable with the given value. So the given value is -2. So I'm just going to replace each of those empty spaces, those placeholder values, with a -2. And then I'm going to evaluate. I'm going to simplify my expression like I just did in the last slide. So using order of operations, we square the -2, which is a 4. 4 times 3 is 12. Then here we have a 4 times a -2, which is -8. And then here we have a -5. So once again, the order that you do these doesn't matter. You could take 12 and then -8 and then -5. Okay? You could take -8, -5, combine that, and then subtract it from 12. Regardless, you get 12 minus 8 is 4. 4 minus 5 gives you a -1. Okay? So that would be by hand, just plugging in the values and simplifying. And now, if you're going to use the TI-89, there's something that's called a with key that you can use. Okay? On a TI-89, if you type in the expression exactly as it appears, so if we were to type in this expression as 3x to the power of 2 plus 4x minus 5, you could use the with key. The with key is the vertical bar that's located right to the left of the 7. So there's vertical bar, and then you could tell the calculator what you want your variable to be equal to. So x equals, and then -2. Okay, so if you enter this line on your TI-89 and then hit enter, it'll give you the correct solution. Okay? So step 1 on the TI-89 is to enter the expression. Step 2, use the with key, which is just the vertical bar. Step 3, identify what you want the x to equal. So x is equal to whatever the number is. And then the last thing is to hit the enter button, and it'll give you your solution. Okay, so all right, so let's take a look at that. If we take our expression 3x squared plus 4x minus 5, and then use the with key, again, right to the left of the 7, right below the equals. X equals, again, tell it what you want it to equal. In this case, -2. Now notice, anytime you're using the negative as the indicator, meaning the left side of the origin on a number line, you have to use this bottom key. This bottom key is the change of sign key. It's different from this subtraction key. And you can't put subtract 2. This is an operation. It's looking to be performed on something. It's not an indicator of what side of the origin or what side of 0 a number lies. So use the change of sign key, and when you do that, hit enter, you get confirmation that -1 is the correct answer. All right, so I'm going to have you do these examples here in just a second, but I want to talk through this first one. Okay, if you are going to use your calculators for these, and most of these, and you'll see when I go through examples, probably easiest just to do it by hand. But if you're going to use your calculator, this first example shows two things that I want to make sure you're aware of on your TI-89. Okay, the first is this mn is implying multiplication. Okay, so this is implied multiplication. It doesn't specifically say m times n. So if you enter mn on your calculator, it thinks that you're naming a single variable with 2 letters. It thinks that mn is the name of one variable. And so you have to explicitly multiply. So that's the first thing. So if you enter this on your calculator, you need to explicitly say m times n. So when you look at your letters on here, the letters X, Y, Z, and T are along this top row. Those are the most commonly used ones, so they have their own buttons. But everything else, all the other letters are just in alphabetical order along the top of these keys, and you access them with this alpha key. So if you're going to type in the expression m, hit the alpha key, and then the number 5, where m is right above that. Explicitly multiply alpha key 6, gives you n. And then divide by 6, and then add 10. So notice I didn't put any my own grouping symbols. I just wrote it exactly as it appears. Okay, so that explicit multiplication is the first thing. The second thing, we use our with key. we have two variables. If you have more than one variable, the way to identify the substitution of it in the evaluation and the with key is you go ahead and type the first one. So alpha 5 for m equals 7. And what you're going to need to do is you need to put a space, the word and, a space, and then n equals. So you have to separate the additional variables by the word and. And again, it's a simple way to do that. You do have to type the word and. So because we're going to be using alphabet keys, the alpha keys for many keystrokes, I'm going to go ahead and lock it. Alpha lock can be accomplished by either hitting second and then this white button, or just hit the white button twice. It toggles it from a single key alpha to alpha lock. So once this A is highlighted here on your display, it's locked in the alpha mode. So I can use space. Space is here, this bracket under or above the change of sign key. So space, then the word A and D, space again. And then we're going to take our second variable n. So now I'm done with my alpha key, so I can toggle one more time, get rid of the alpha lock, hit the white button, set it equal to, and n is equal to 6. And when I do that and hit enter here, I get my solution for this, which is 17. Okay, now if I did this by hand, I'd confirm the same thing, right? M is 7 times 6 divided by 6 plus 10. And now, when you look at this, do multiply and divide have a priority between the two of them? No, there's no priority. You can multiply or divide, it doesn't matter. So which would be easier, to take 7 times 6, get 42, and then divide by 6, or take 7 times the quantity 6 divided by 6? What's 6 divided by 6? 1. And then times 7 is 7. Okay, so again, you can kind of manipulate those. There's no priority on multiply and divide, no priority on add and subtract. All right, so let's take a look at problem 2. Here, if you just substitute these in, so substitute a 1 in for B and a 6 in for A. And when you're looking at that, 1 minus 1 is 0, 0 squared is 0, and then 6 squared is 36, so that gives you your answer very quickly and easily as 36. And if you entered it in your calculator, it would take a long time to type in the ands. Okay? So you'd want to be careful. Okay, now, the one other way that you can do this, you could enter these on your calculator in this substituted form. So you could enter parentheses 1 minus 1 squared plus 6 squared. If you do it this way, anytime you take something to a power, I would emphasize put it in grouping symbols. And because if you don't and you are substituting in a negative number, it's likely that the order of operations will mistakenly calculate something different than what you had intended. Okay. All right, so this last example, again, if we do it by hand, we can substitute in our value. So if x is 9, so we get 9 minus 9 minus 9 minus, and y is 1 cubed. Okay, well, we can just go through and simplify what we have working from inside the parentheses and out. So here's our innermost parentheses. Cube the 1, we get a 1. 9 minus 1 is 8. So here, as we work out, we get 9 minus this 8, which is 1. And as we work out, 9 minus 1 leaves us with our answer, 8. This last problem here, if I type in the expression x minus parentheses, x minus parentheses, x minus y to the third, close two parentheses. Again, I entered it exactly as it appeared, didn't add anything different, didn't take anything away. And then I'm going to use my with key, vertical bar, and I want to substitute x is 9, alpha lock it, space, and, space. I can deselect the alpha or toggle out of that. Y equals 1. And when I hit enter, it confirms for me that 8 is the correct answer.